Hi and welcome back to class of Design of Machine Elements. I am Hitesh Raiyani, Assistant Professor at LJ Institute of Engineering and Technology. This is lecture 32, Chain Drive. The learning outcomes of this lecture is to learn the power transmitted by chains, power ratings and service factor. So in this lectures we first see the power transmitted by chain, then power ratings and service factors. So let's now power transmitted by chain. As we know, the power transmitted is nothing but the force multiplications of force and velocity. Now in this chain drives we consider two cases. First is the power transmitted by the chain on basis of braking load is given by P is equal to WB into V divided by N into Ks. So here WB is the braking load in Newton, V is the velocity of chain in meter per second, N is the factor of safety, and Ks is service factor, and is equal to Ks is equal to K1 into K2 into K3. So Ks is nothing but the multiplications of factor K1, K2 and K3. Now the power transmitted by the chain on the basis of bearing stress is given by P is equal to sigma P into A into V upon Ks. Here sigma P is the allowable bearing stress in megapascals or Newton per mm square. A is the projected bearing area in mm square. V is the velocity of chain in meter per second, and Ks is the service factor. So according to braking load, P is WBV by N into Ks, and according to the bearing stress, P is sigma B into A into V upon Ks. Now, power rating for power rating for simple roller chain depending upon the speed of smallest pocket is given in the following table. So here you can see one table, and the table shows the power rating of simple roller chains. And if you see these tables, you can see that there are first column of speed of smaller socket or pinion in RPM. So there are different speed of pinion in first columns, and you can also see the power rating is based on the types of chain. So there are different types of chains mentioned in tables like 06B, 08B, 10B, 12B and 16B. So if we have to taken the value of power rating, we have a pinion speed in RPM, and also we know the types of chain. So for example, if the pinion of speed is 1000 RPM and we have a chain type 12B, then according to our condition, that is a power rating is 15.65. Same this way you can calculate power rating for any condition. You can see that for 500 RPM pinion, for 500 pinion RPM, you can say if your types of chain is 12B, then your power rating is 5.01. Now, next is the service factor Ks. As you seen in the power equations, there were service factor used, and service factor Ks is the product of various factors such as load factor K1. So K1 is the load factor, lubrication factor K2 and the rating factor K3. So according to the definitions of service factor Ks, it is the product of the K1, K2 and K3. So service factor Ks is equal to K1 into K2 into K3. Now to calculate the value of service factor, we also take the value of this all factor like this K1, K2 and K3. So the value of these factors are taken as follows. Load factors K1. So load factors K1 can take is equal to 1 for constant load. So whenever there are constant load, you have to take K1 is equal to 1 in your chain design. K1 is equal to 1.25 for the variable load with mild shock. So it is equal to 1.5 for the heavy shock load. So K1 taken 1.5 when there are heavy shock load. Now next is lubrication factors, and the value of lubrication factor K2 you have to take is equal to 0.8 for the continuous lubrications, and K2 is equal to 1 for the drop lubrications, and K2 is equal to 1.5 for the periodic lubrication. So according to conditions of lubrications, you can take the value of K2, that is the lubrication factors. Now next is the rating factor K3. So value of rating factors you have to take K3 is equal to 1 for 8 hours per day. So here to calculate the rating factors, you have to consider the operating conditions of chain drives. So whenever there are operating conditions 8 hours per day, you have to take K3 is equal to 1 in your designs. K3 you have to take 1.25 for 16 hours per day, and K3 is equal to 1.5 for the continuous service. So if there are continuous service, then the K3 is taken 1.5 in our design problems. So according to given problems, we have to take value from these configurations and we can calculate the surface factor Ks. Now next is the number of teeth on smaller or driving sprocket or pinion. So whenever you do the designs, you have to take the value of teeth on smaller pocket or driving pocket, or you can say the pinion. So for that you have to use this table. The table shows the number of teeth on smaller sprocket, and if you see that in tables, to calculate the number of teeth on smaller sprocket, you must know the types of chain and velocity ratio. So for example, if your types of chain is roller and velocity ratio is 3, then roller chain with velocity ratio 3, the number of teeth on pinion that is taken as 25 from this table. Now consider one worksheet problems. Design a chain drive to actuate a compressor from 15 kilowatt electric motor running at 1000 rpm. So here a chain drive is used to actuate compressor from 15 kilowatt electric motor running at 1000 rpm. The compressor speed being 350 rpm. The minimum center distance is 500 mm. So X is given, that is 500 mm. The compressor operates 16 hours per day. So this condition is we have to take the value of K3. And the chain tension may be adjusted by setting the motor on sides. So this is the given data, and according to this data we have to design the chain ties. So given data is rated power is 15 kilowatt, and one that is the electric motor speed that is given is 1000 rpm, and 2 is the compressor speed that is given 350 rpm, and center distance is given 500 mm. So x is given 500 mm. So this is the worksheet problems. You do yourselves. We will discuss these problems in our next lectures. So in these lectures we learn the power transmitted by the chain on the basis of bearing stress and braking load. Also we seen the service factors and different factors K1, K2 and K3. So this is the worksheet problems. Do yourself. We will discuss in our next lecture. Thank you.